So we're looking at stereochemistry now, pointing out how molecules can look very similar but actually not be identical, which would give them different properties, especially in systems that are like biological systems where the three-dimensional shape of the molecule affects how it interacts with other molecules. So the three-dimensional positioning of some of these groups of atoms in space makes these two molecules different. I wanted to just use a model to illustrate that. So here I have an OH and a hydrogen on the same central carbon. So here's my model of that structure. Here's my central carbon. I've got the OH and a hydrogen in the same plane. Got a methyl group pointing out at me, which is what I have here. The methyl group with the solid wedge, the ethyl group with the dashed wedge, and the ethyl groups pointing away. So I've got both of these structures. They are mirror images of one another. Right, so the dotted line there is representing a mirror. So if this one molecule on the right here, we're looking in the mirror, the other molecule would be its reflection. Right, the ethyl group's farther away from the mirror, so it reflects into a farther away from the mirror position on the other side. Same thing would happen if you look in a mirror and you put your hand behind you. It would look like it's going behind your reflection as well. So same thing I have right here. These two models are a reflection of one another. Right, if my mirror is right down the middle, the OH on one side is reflecting the other. The ethyl group over here is reflecting the ethyl group on the other side. So those are clearly mirror images of one another. And we want to show that they're not superimposable. Right? So clearly if I take this structure and try to get it to lie on top of the other one and have everything line up, I can line up the two methyl groups. Right? They're like right on top of one another. But then as I notice over here, the hydrogen of one molecule lines up with the ethyl group of the other. They're not lining up. So maybe I want to flip the molecule over and maybe try to see if it'll line up then. Okay, so now I can get these two ethyl groups to line up and the two methyl groups in the front, but then on the other side of the molecule, things are not superimposing. I have this OH group lining up with the hydrogen, the OH group here lining up with that hydrogen. So I can't get all four groups to line up. And so these two molecules are enantiomers. They are mirror images of one another. They're isomers, right? They have the same number of carbons. Each carbon has the same things attached to it. The only difference is the center carbon here, even though it has an OH, an ethyl, a methyl, and a hydrogen, just like this one has an OH, an ethyl, a methyl, and a hydrogen, they're not positioned in space in the same way. If I want to make this molecule exactly like the other one, I can't just do that by rotating any of the single bonds or flipping it over in space. There's no way to get them to be superimposable and to line up directly on top of one another. So they're non-superimposable, but they are mirror images, and that is the definition of a pair of enantiomers. That means that they're not identical, and they are going to have different spatial properties, including some of the ways that they might interact with spatially specific three-dimensional molecules in biological systems.